Hey, what's up, guys? This is Sheng here. So this time, LeetCode number 782, transform to chessboard. Okay, so this one, you're given like n by n binary grid, right? And now we can make some moves. So in each move, we can swap any two rows or any two columns. Okay, and our task is to find the minimum number of moves to transfer the board into a chessboard. Okay, so a chessboard is like this. So there's in four directions, right? There's no, basically, there's a 1, 0, and then a number 1, and then 0, 1, 0, 1, 0, 1 on each row and each column, right? So that's the our goal for this moves here. And if there's no way to transform this grid into a chessboard, then we return -1, right? For example, we have this kind of original board, right? So in order for us to make it into this one, right, we have to make some movement. So basically, we transform into this one, and then we transform into this one. Basically, we swap the first and second column, and then we swap the second and the third row, right? So that's that. And then for this one is 0 because it's already a chessboard, right? And this one is -1, right? And why is that? This one is it's pretty obvious because no matter how we swap either the row or column, those two ones will never be split, right? So we can never make this one to 0, 1 to 1, 0 because it wouldn't, right? Because they are kind of like stick together. There's no way we can split them, right? So yeah, so that's it, right? I mean, so for this problem, actually everything is about observations and checking those kind of different special cases, right? So I mean, so first, how do we know if this board can be transformed, right, into a chessboard? Okay, so we don't know the starting state, but we know the final state, right? So the final state is, like I said, everything has to be has to be one of each other, right? So it has to be a 1, 1, 0, 1, 0, or 0, 1, 0, 1, right? So what does this mean? It means that for all the rows and the columns, there can only be 2 rows and a column at the very beginning, right? And why is that? Because okay, uh first, the final state is like this. As you guys can see, we can only, for example, this one, we only have two type of rows. So one is the 1, 0, 1, 0. The other one is 0, 1, 0, 1. Right? So we're only looking at the rows for the time being, right? So what does this one mean? It means that uh, at the very beginning, there can only be at most can only be exactly 2 kind of rows at the very beginning before we do any moves or swap, right? And why is that? Because so first, okay, so we only have two operations. One is to swap rows and one is to swap columns, right? So if we swap rows, obviously there won't be any change. So the row itself will not be changed, right? So if we swap the columns, right? So whatever on one side will also be changed at the same time, right? So for example, if at the beginning you see we only have two kind of rows at the beginning. One is 0, 1, 1, 0. The other one is 1, 0, 0, 1, right? So since we know at the end we only have 2 kind of rows, so it means at the beginning we must also have two kind of rows, because if we only have, because no matter which row we swap, because everything on that same, sorry, how many column we swap, everything on that column will be swapped all together, right? So which means even though the sequence of the column might be changed, but the type of rows can only be at 2, right? So it means that, you know, so we only have this one, but if we have another row like this 1 0 1 0, right, then obviously, no matter how we swap the columns, there's no way we can get to this, right? Because, we'll have like three different columns, right? So this is one. Actually, we'll have four, right? So this one is one, this is one, this is the other one, right? Because like I said, every time we swap the column, the entire column will be swapped. So there's no way we can make a different column. Which means, since there's no way we can reduce this three kind of rows into two, it will always be three different rows, no matter how we swap the columns. Okay, so that's the first thing we need to check, right? So basically, we want to check if there's only two kind of rows, right? I mean, same thing for the column, right? So, but for now, we're just only talking about the rows, right? So that's that. Okay, so first, if we know, okay, then there are only two kind of rows, then what's next? The next is kind of also kind of obvious, is because in order for us to have this kind of different like chessboard, like style board, the count of 0 and 1, the difference cannot be greater than 1, right? So for basically, if the length of the row is even, then they have to be the same, right? And if the length of the row is odd, then the difference can only be at most. I mean, the difference has to be 1, right? So which means, let's say if there's a row like this, 0 0 1 1 0, this is fine, right? But if 0 0 0 1 0, this will be wrong, right? Because there's no way, because we know we need at least we need 2 1s and 3 zeros, or 3 1 2 0, right, to make it like a chessboard, right? Okay, so that's the second one, right? And what's the third one? The third one is like this. Okay, so if these two are like those two conditions have already been met, then the last one is that, for those two different kind of rows, they have to be complement to each other, right? What does it mean? It means that, if one row is like this, the other row has to be like this, has to be 1 1 0 0 1, right? Because in the end, right, everything has to be different. I mean, every adjacent row or column has to be different, right? So I mean, which means this 0 and 1, they have to be complement to each other. Basically, if we have this one here, like, this will also be wrong, right? Because like I said, there's a 1 and 1 here, right? So even if there are only two kind of rows, right? And I think the last thing we need to check is so we're checking the numbers, the number of ones and zeros for each row, right? We also need to check the total number of different two kind of rows has to be at most, the difference has to be at most 1, right? Because so for this one, if this one is 2 and 2, this is fine, right? I mean, but if this one has 4 rows and this one has 2 rows, this is also gonna be wrong, right? Which means, the different of rows and different kind of rows has, I mean, the difference, the count, difference of the count can also be at least 1, depending on the length of the n. If it's odd, then the difference will be 1, right? And if it's even, right, the difference will be 0. Okay, so I think that's the three things we need to check, right, before we can be sure if we can transform this board into a chessboard, right? And once we know that we can check this, we can transform this into a chessboard, and then how do we know the number of movements to transfer it into that, right? I think it's pretty simple because we know the final state, right? It could be either 1 0 or 1 0 or 0 1, right? And so the in the final state, basically we'll do some swap for the rows, and we'll also do some swaps for the columns, right? So the total movements for us to make it a chessboard is the total number of the rows moves plus the column moves, right? It doesn't really matter which one comes first, but in the end we need this number of row. We need to move some rows, swap some rows, and we need to swap some columns, right? And so that we just need to know, right? Because for the rows and columns, we also have like two different kind of possible ways, right? So if the n, right? So if the n is odd, then it means that the the starting number has to be the number who has more count, right? So for example, this one, right? For example, this one we have 0 0 1 1 0, right? At this moment, right? I mean, the first one has to be 0, right? Because in the end, we know we want 0 1 0 1 0. Okay. But if it's even, right, then we'll have two options. We can either put 0 at the beginning, or we can put like 1 at the beginning, because for even we have what 0 0 1 0 1 or 1 0 1 0, right? And we need to check both cases in that for the even length. Let me try to start coding, right? And then I'll explain more. So first, like I said, we need the n, right? Because we need the n to check if it's odd or even, because that'll make a difference, right? Okay, so I think since we need to check both the rows and the columns, right? We need a row count. Okay, row count is going to be a counter of what? Basically, we need to check. So first we check how many different rows we have, and how many different columns we have, right? So for the rows, what we can do is we can convert this board to a tuple, right? So this is how we basically the map will basically convert each of the element of the board, which is like a list, into a tuple, because in the Concord or in the dictionary we cannot use a list, right? So we have to use a tuple as a key, right? That's why first we need to convert each of the element into a tuple, and then we for a list of tuples we can then convert it into a counter, right? And for how about the column, right? So for the column, it's a little bit tricky, For column, what we can do is like this. We can do a zip, You guys, if you guys don't know, so we do a star of board. What does this one do? Basically, this one will remove the outer bracket. This one will just give us like an iterator of the everything inside, which is a list of a list, right? And then if we do like a zip of that, so basically we'll zip of 4 lists, it will give us like a list of each element, right? Of each of the elements of each of the lists here. Basically, if we do a zip here and then we do a like this, remove one of the brackets, it'll give us the a list of column. It's going to be a 0 0 1 1 1 1 0 0 1 1 0 0 and 0 0 1 1. That's how we do. That's how the zip trick works in this case. Okay, and we'll do the same thing for both the row and the column, right? And then we just treat those them as the same, right, as the row count and the column count. Okay, because here in the end, somewhere here, we're gonna have like return the answer, right? Okay, so let's check one of the count here. Let's say, for example, we want to check the rows, right? So first we check if only has two type of rows or lines. How about this? Okay, basically, if the length of the count is not equal to 2, right? We return -1. Okay, and then what do we check? We check if the count of two type of lines difference, okay, is at most 1, right? How do we check this? We can do this. We can do a sorted of count dot values, right? So that will be the, it could be like 4 5 or 4 4, right? If this one does not equal to what? Equal to n divided by 2 to n plus 1 divided by 2. And then we return -1 as well. So what does this one? It means that, okay, so if n is equal to 8, right? We're hoping to get 4 and 4, right? If n is equal to 9, it should be 4 and 5, right? That's what this one checks. Because after sorting, we have, if n is 8, so this two will have, this one is 4 and 4, right? So if the n is 9, this one will be 4 and 5. Okay, that's how we check that, right? And the third one is checked what? So we check each type of line has count difference of 0 and 1 equals to at most 1, right? Similar like this one, right? Well, for a line in count, right? Let's do another count. It's going to be a counter of line, right? So here we do the similar thing. We have for if sorted of count dot values, right? If this one is not equal to this, right? Similar like this one, and then we return -1, right? So here we check for each of the line type. We will also want to make sure the number of 0 and 1s, the difference is at most 1, similar like this one, okay? And the last, oh, there's one more thing we need to check. So the last thing we need to check is that those two kind of lines check, okay, sorry. If two type of lines are complementary, right? Is it complementary? Yeah, I think I'm spelling correctly here. And how do we check that? Okay, so let's say we have 0 0 1 1 0, and the other one is 0 0 1 0 0 1, right? So what do we want to check? I think we just need to check if everything are like either 0 or 1 or 1 0, right? And how do we check? We just can do this. If not all of x, no, for x, y in zip, oh, we need to zip line 1 and line 2, right? So we have line 1 and line 2 equals to the count, right? When you zip these two lines, line 1 and line 2, okay? we need to check if x or y is equal to 1. Okay, right? And then we return -1. Right, so this is all, right? We want to make sure if everything, all the pair are equals to 1, because 1 means true, right? This is one. As long as there's any pair that has 0, 0, 0, or 1, 1, this one will become to 0, right? 0 means it is false, right? Which means this will return -1. Okay, see, so now after checking these 4 things, we can ensure that, okay, somehow, right, after some moves, we can be sure the this board can be transformed into a chessboard, right? So the next thing is that we just need to count, right? We just need to find out what are the best options here, the best of a tactic or strategy to make the moves. Okay, so in order to do that, right, we need to do two things to check things. So we need to know, like, based on the number, the parity of the n here, we need to check different things. So first one, if the n is odd. Odd means what? Odd means if n is odd, right? Odd, then the first one, right? The first number has to be the majority one, right? Majority one. So like I said, if we have 0, 0, 1, 1, 0, then for this line, right? So the first one has to be, because the end of state we already know, it has to be 0, 1, 0, 1, 0, right? So this is what I mean, the majority one, which is 0. Okay. And to check that, we'll only check either line 1 or line 2. I think for at this moment we check line 1 is enough. So this is because, at this moment we already know we only have 2 types of rows of lines, right? And the lines are complementary to each other, which means, let's say the type 1 is like this, right? So the type 2, we already know it has to be like this. Okay, right? So if we can make the type line 1 into 0, 1, 0, 1, 0, right? And then we know that, the line 2 has to be 1, 0, 1, 0, 1. Okay, we are already sure of that. That's why, for this 2 line of type, we can only check one of them, which is enough. Okay. So so here, so let's go back to here, right? At this moment, we just need to know the expect one. So for me, I use the expect one to 1, right? If line 1 dot count 1 is greater than line 1 dot count of 0, right? Else 0. Okay. So basically, this is the first one that we're expecting for the line 1, right? If the count is 1 is great, has more, then I use 1, right? Otherwise, I use 0. And then the moves, right? So the moves will be 0. And then for x in line 1, right? So the moves will be like this. Okay, x to expect, and then so here I have expect. I'll explain what I'm doing here. Okay. So here I have 0, 0, 1, 1, 0, right? So we know the end goal is like this. We know the end goal is like 0, 1, 0, 1, 0, right? That's why, for the expect, this is obvious, right? Because for expect, the first, if it's 1, if it's 0, and then the next one will be 1, and the next one will be 0, and then 1 and 0 again. That's why I do XOR, so that I can flip the value of the expect, right? And as for how many moves we need, right? Basically, the moves we need will be the difference of these two, right? Basically, if they're the same, then it means we don't need to move them. But if they're different, then we know we have to move them. That's why I do a x or the expect, which is this one. Basically, if they're different, then this value will be 1. Okay, so here we have total moves, right? After that, but in the end, the actual move is like we need to do a moves divided by 2. We need to do a moves divided by 2, and the reason being is that so for example, this one, right? I mean, this one we're gonna have 2 different moves here, but actually the number of movements we need is 1, right? Because here we're double counting the operations, right? Because one of the swap will, I mean, means like 2 difference here, right? That's why in the end we have to do a moves divided by 2, right? And then here that's why what we have is like this, right? So which means if it's odd, then we only have one option, which is the pick start from the one that has more like count, and then we count that the moves, and then we divide it by 2 in the end. Okay, right? Else if n is even, right? Right? If n is even, try both 0 and 1 to start. Okay, right? So we have the moves in here. I'm doing something like this. I know my implementation may not be the cleanest one. So for this one, I have 0 and 1, right? And I have the current moves equal to 0. And for x in line 1, right? So current moves x. Yeah, basically I'm just copying here, copying this one here, except the moves, current moves. Okay, and then current moves gonna be current moves divided by 2, right? And then here we have moves equals the minimum of moves of current moves. Actually, let's do this. Yeah, same thing here, right? Moves divided by 2. Okay, and in the end, return the answer. Right? Basically, here we'll try both 0 and 1 to start with, and then we'll get the minimum one, right? Among those 2 different options. Yeah. So run the code. Return is not defined. What? Yeah. Right. So I think that's it, right? I know this one's not. That's why I can see why this one got a lot of downvotes, because I think the most important thing for this one is to check all the cases to make sure we can actually transform this board into a chessboard. And after that, right, based on the parity, right, we're gonna have different approaches, right? So where when it's odd, we can only there's only one option. We basically try that. We try the one with more count to start with. Otherwise, we'll try both, right? And then from the very outer loop here, we do this thing for both the row and the column, because we know, we need to make some like swaps for the rows, and we need to make some swaps for columns. That's why we're gonna accumulate those 2 different kind of swaps together to get the answer in the end. Yeah, I think that's it, right? I mean, yeah, nothing too fancy, just a bunch of like implementations and observations. Cool, and thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.